Hey guys, I'm Lucas, also known as the Math Wiz. You can call me either, I don't really care. But this video will be my first video ever for this channel, and it will be an intro to stats. Now this will be the first in a series of videos where I go through the 5 steps to a 5 book for AP statistics. So, without further ado, let's just get started. Okay, now 5 steps to a 5 opens up with tips for taking the exam, and blah blah blah. That's sort of for if you've already taken most of the class and you need to start studying for AP exams. I'm just going to start with the learning part. And the first thing it goes through are just some key terms that you'll need to know in the very beginning, and of course later on, but these are just your basic terms. And the first thing it goes over is quantitative versus qualitative. Okay, so the first time I did this, I realized what I said was a little bit misleading in what quantitative and qualitative data were, so I'm going to go back over that, redoing it. Okay, so quantitative data is data that can be counted. It's data that's numbers. So, the example I'm using is that I have 20 books in my library. That is a nice number. It's just 20 books in my library. Now my friend has 25 books in his library, and my mom has 30 books in her library. Okay, these are all numbers, and those numbers, that is quantitative data. And I could use that to get the average number of books in a person's library. Well, the average number of books in the library of this data set would be 25 books. Okay, so qualitative data would be different. It would be categorizing these books if we're going to use the same data set that I've used here. So qualitative might be that my library is all just for fun books. Reading is fun, yay. All I have are fun books in my library. But my friend, he likes science. All his books are science books. Mom, she teaches sociology. All her books are sociology. Okay, now these aren't numbers. These are all categories, and that's what qualitative is. Qualitative will be words over numbers, and that will pretty much always be the case. Now AP exams, whether you're taking stats or any math or science course, you might be asked to describe your answer or explain your answer or reasoning quantitatively or qualitatively. And so basically quantitatively would be describing or answering your question with numbers and math, while qualitative would be describing it using words, categorizing things. But for data reasons, quantitative is numbers, qualitative is categories, pretty much. And that could be things like gender, political party, your eye color, ethnicity, all those kind of things are qualitative when quantitative is numbers. Okay, moving on. So the next thing it goes over is discrete and continuous data. Now, discrete data is data that you can count. It's finite. Discrete data is finite. Like if you're gonna flip a fair coin 10 times, then you're gonna have 10 results, and they can either be heads or tails, and we can denote that 1 or 2. And so if you flip it 10 times, let's say we get 1, 1, 2, 1, 2, 2, 1, 1, 2, I don't know, is that 10? Sure. Anyway, you have 10 results, and that is discrete data. Now look at those brackets, though. So you have 10 points, and you got 5 heads and 5 tails here, and that's going to be your discrete data. It's countable, and it has a finite number. Now, continuous is something that can't be measured. It's going to be infinite, usually. And so continuous would be like what time of day, like if you record the time of day, whatnot, that will go on infinitely. It'll always be, you can do 1024 or 1024 in 13 seconds and 14 seconds. Either way, the data on the time of day will be continuous, and it will never end. It's infinite. Okay. Moving on to the next thing it talks about, and that is descriptive versus inferential statistics. Now, descriptive statistics are going to be the data that you actually collect. It will describe what you have found. And so let's say in a population of 100, you take 10 of those people, and from these 10 people, you find that only 3 of them like math. Of these 10 people, only 3 like math. And you find that 7 don't like math. And so, oh gosh, it's moving around on me. Okay. Pardon my handwriting, but you find this from these 10 people, and this stat that you have right here is going to be your descriptive stat, and from there you can take whatever you want from that, analyze that data, blah blah blah, do whatever you want with that data. Average hit, I don't know, of the 10 people, 30% of these people like math, 70% don't like math. You can take stuff from that data that you have collected. Now, inferential data would be like saying that of this population of 100, you can take from that data that around 30 of the 100 will like math. And so that's inferential. You're taking something from descriptive data and you're making it inferential by applying a sample size to entire population. Okay. And so back to the descriptive and inferential stats, you have, well, really, inferential isn't so much statistics, but parameters. So we have parameters for statistics. Now statistics, that will be the 3 people like math and 7 people don't like math. And the parameters of that would be 30 people like math and 70 people don't like math. Those would be your parameters. Your statistics is the data that you've actually gathered. This is a fact. It's a statistic. That's a fact of the 10 people that you took out, that 3 people like math and 7 people don't like math. But if you look at parameters, you've now taken something from the smaller sample size and applied it to the larger population size, and you have 30 people that like it and 70 people that don't, and that would be a parameter. Okay. Let's move on to the last part of the overview of statistics and basic vocabulary. It goes on to collecting the data and how you should go about collecting it. And it talks about experiments or observational studies. Those are 2 vocabulary words it has highlighted. I don't think they're incredibly essential to like the point that it's trying to make, but you have observational study and experiments. And so it doesn't really go over the difference of it. It just talks more about how if you're going to take descriptive data and then turn it into inferential, you need to make sure that it's random. It was a big point that it made in this introduction section that everything needs to be random. And so it gave a good example, and I'll use that example from the book. And it said that a newspaper, magazine, whatever, would predicted the outcome of the Franklin Delano Roosevelt election, his first one. And he predicted that, and the study predicted that Roosevelt would lose by a landslide. And as we know today, that is not true. And basically the place went bankrupt because of the whole thing. And it was wrong on this fact because it didn't have truly random data. And so you have to look at that data, and you can see that 1936, it was the heart of the Depression. Things were really bad for America. So not a lot of people had subscribed to this to this magazine, newspaper. It's a magazine called the Literary Digest. I'm looking over at the book now. But anyway, the point is that during this Depression, not many people could afford to buy magazines, but the people that could were actually typically Republican. Republicans and their money, for whatever reason, a study could be done to figure that out, but for whatever reason, most people that subscribed to magazines were Republicans, so whenever they did they surveyed 10 million people, and that's a pretty good sample size, and they'd done this in the past and done great in their predictions, but because it was no longer random, because generally people that could still afford magazines were just Republicans, they got mostly people voting for the other guy, and Al Flandin is the name of the other guy, that ended up losing the election. But because it wasn't random, the stats that they had were wrong, and they couldn't come up with good parameters later. Remember, statistics are what you actually collect, parameters are what you can assume, well, not assume, but infer from your data. And so, because of that, it was wrong. And you have to make sure whenever you do a study, everything's random. You're not picking, specific types of people that will likely go one way or another in the study. So that way you can get the best parameters possible. Okay, I'll end the video there. It's probably a little bit longer than it needed to be, but it's just an intro thing to get this whole tutorial thing going. And so I hope you all enjoyed it, and I look forward to seeing you in the next video.